Hello guys, let's solve this integral right here, and in the thumbnail I've given guys the hint to know your multiples. So we have sine 2x, so we should obviously know what the multiple angle formula for sine 2x is. So sine 2x is simply 2 sine x cos x. And I'll also give you guys another multiple angle. That one is for cos 2x, which is cos square x minus sine square x. So we somehow have to use this integral, or sorry, this fact, this multiple angle in this integral right here. And if you directly plug that in, you really won't know where to go from there. But let's start with what we have in this integral in the first place. So we have our sine 2x and our sine x plus cos x whole square. So let's just expand this right here. So in the above we'll have sine 2x, and below this will just be sine square x plus 2 sine x cos x plus cos square x. Now we can see we have our 2 sine x cos x over here, which is just sine 2x. But another interesting fact about sine x plus cos x whole square is that we have sine square x plus cos square x, which we know is just 1. So simply we have our 1 plus sine 2x. Now from here it's kind of easy to solve this integral. So all you have to do first is introduce the 1 and subtract that 1. So we will have to split this into two fractions, namely this minus that. So first of all, it will be 1 plus sine 2x by 1 plus sine 2x, which is just 1, which is the integration of dx minus the integration of 1 by 1 plus sine 2x dx. Now this is just x minus. Now what about the integration of this? Well, what we can do is we can go back one step. So this is 1 plus sine 2x, which came from this. And in fact, I'm going to use this method right here for going back and rewriting this step, since 1 plus sine 2x is just that. But what you can also do is you can go back again from here to sine x plus cos x whole square, and that also works out very nicely. So I'll also do that method, but after I finish with this one. So this will be dx by, which is sine square x plus 2 sine x cos x plus cos square x. Now typically in these types of trigonometric integrals, what you'll have to do is multiply the numerator and denominator by sec square x. So this will be x minus sec square x by, now we'll have to ask yourself why sec square x, because here in the numerator we'll have sec square x dx, and well, tan x, if you differentiate it, you'll get sec square x dx. So if we get tan x right in the denominator, or everything in terms of tan x, we can simply substitute that in. So let's see how that works out for this integral. Now sine square x into sec square x. Sec square x is just 1 by cos square x. So this becomes tan square x. This becomes 2. 1 sine x and 1 sec x makes up for tan x, and 1 cos x and sec x cancel each other, and this whole thing cancels, giving us 1 dx. So as you can see, this whole thing is in terms of tan x. So just let u equals to tan x, such that du will be equals to sec square x dx. So we will have our x minus du by u square plus 2u plus 1. Now this integral is quite easy, because you have u square plus 2u plus 1, which simply is u plus 1 whole square. And u plus 1 whole square, you can rewrite it as u plus 1 to the power minus 2 du. Now simply from here, it is just a linear term to some power. Use the power rule. This is x minus 2 plus 1 by minus 2 plus 1. So minus 2 plus 1 is just minus 1. Minus minus will in fact be plus, and we'll have u plus 1 to the power minus 1, which is 1 by u plus 1. But u is just 10x, so 10x plus 1 and plus c, and that is our answer. So this is one way you can do it, but I'll also do another way in which you'll go back in a future video. If you learn something new, please like and subscribe. Thank you.